Well, this is our product HPSP, Hybrid Peltier Solar Panel.
Basic parts are the parabolic mirror, the photovoltaic panel, and beneath that you have the thermoelectric generator, behind which a heat sink is installed.
The charge controller which we are using is a Texas Instruments EVM 24650 synchronous charge controller.
This prevents the over discharge and the overcharge of the battery and regulates the current. Light from the sun falls on the parabolic reflector, which focuses the light onto the photovoltaic panel. The panel absorbs a part of this energy and the remaining amount of energy is dissipated as heat.
Well, only 30% of solar energy is utilized by PV cell and remaining 70% is dissipated as heat. This dissipated heat is absorbed by our TEGs which we placed under the solar panel and EMF is generated. Okay, what are TEGs? TEGs are thermoelectric generators. On maintaining temperature difference between the surfaces of TEGs, we can produce EMF.
So we are using here water cooling systems to maintain low temperature. So one side of the thermoelectric generator.
The heat dissipated from the thermoelectric generator is carried away by the cooling water and it raises the temperature about 40 to 45 degrees and it is used for general domestic purposes.
Well, in general, 5 into 5 inch solar panel generates 1.5 watt of energy. In our product, we use a similar solar panel and the output of our product is 3.5 watt.
We double the power output from the same amount of area. This is a hybrid Peltier solar panel in action. On the bottom right is a graph. On the y-axis you have the power generated by both the thermoelectric generator and the solar panel, whereas on the x-axis you have time. We have started the experiment at around 12 o'clock and you can observe that the power output at this time is the maximum. This is because the sun is exactly overhead and the intensity of radiation reaching the panel is very high. But as time progresses, the sun moves and the intensity comes down, so does our power output.
Well, the HPSP is seemingly a great product the way it is. One of the great advantages that it has is it's using multiple energy mechanisms like the light energy, the heat energy, electrical energy, and at the end, I think it should be able to match the customer's requirement, both in terms of cost, efficiency, the product's ability to be able to meet the needs of the organizations, meet the needs of the common man. I think it's an extremely important aspect, considering the amount of light energy that we really, the potential that it has for the future. I think definitely this should be a great opportunity to be able to tap into this particular resource uh, for all kinds of needs. It can be the end users at home, it can be the industry, uh, but I think one of the most critical elements is going to have is to be able to utilize better space management, um, and the quality itself is going to be of a great need for the end user. I think that's one very critical element. If this is where it can meet all the design standards, um, I think it's going to be a great product that we really look forward to.